Here today I'll explain about the graph of I'll explain the graph of quadratic expression y is equals to ax square plus bx plus c. Okay, now you see y is equals to ax square plus bx plus c is a quadratic expression where a is not equals to 0. So here I am not going to explain what is actually the shape of the y is equal to ax square plus bx plus c, how it comes. I am not going to explain the sketching of the graph, but simply you have to know that the quadratic expression in x represents a parabola. So there are two types of parabolas depend on the value of a. For example, if a is positive, whenever a is positive, the parabola open upwards. Whenever a is negative, the parabola open downwards. So therefore, the direction of the parabola is depend on the coefficient of x square. Here coefficient of x square is a. So depend on the value of a. The direction of the parabola depends. Okay. Now see, if a is positive, parabola open upwards, and if a is negative, parabola open downwards. In fact, there are three different type of graphs. There is a possibility of three different type of graphs whenever a is positive, and also similarly whenever a is negative, there are three different possibilities are there. So that is depend on the discriminant of the quadratic equation. So what is discriminant? Generally we know that discriminant we can denote it by d. D is equals to 4ac minus b square. Sorry, it's not 4ac minus b square. Actually what is that? B square minus 4ac. So d is equal to b square minus 4ac. Depend on the value of discriminant. Now we are going to draw the three different possibilities of the graph whenever a is positive and a is negative. So totally we have 6 different type of graphs now we are going to see. Now I will take the first case. Y is equals to ax square plus bx plus c, where I am considering now a is positive. Now you see the first case is what? I will take discriminant d is equals to b square minus 4ac, I suppose positive. So we know by the nature of the roots, whenever b square minus 4ac, discriminant is positive. Whenever discriminant is positive, we know that the roots of the quadratic equation ax square plus bx plus c equals to 0 are what? Real, and they are different, that is distinct. So the roots are real and distinct. So first of all, because of a is positive, parabola open upwards, and the roots must be real. So in fact, what is the root of an equation means? The root of an equation means, for example, if I take a curve y is equal to f of x curve like this, y is equal to f of x curve, where it meets x-axis. Where it meets x-axis means what? If I say the function is represented by y is equals to f of x, there is a point on x-axis. Do you know, if there is a point on x-axis, y coordinate is 0. For example, if I say this point is C, at that particular point C, y value will become 0. Means, what do we say? Y value become 0 at x equal to C. So it will become f of C equals to 0. F of C is equals to 0. Means C is a real number which satisfies the equation f of x is equals to 0. That's why we call C is a root. So roots of any equation means where it crosses x-axis or where it intersects x-axis, that is called a root. So here you see d is equal to b square minus 4ac is positive. Therefore the roots are what? Real. How many roots that quadratic equation has? 2 roots. So therefore the graph of ax square plus bx plus c meets x-axis in 2 different points. So now you see, suppose this is now x-axis, y-axis. Now we'll draw the graph of y is equals to ax square plus bx plus c. What is the graph of quadratic expression? Is a parabola. Because of a is positive, it is open upwards. It is a parabola. And the second thing is what? It open upwards. And the third one, the point is the roots are real and distinct. Therefore, the graph of ax square plus bx plus c meets x-axis in two different points. So, the graph of y is equals to ax square plus bx plus c looks like this. Y is equals to ax square plus bx plus c. Now we can see here, this is alpha if I say, and this is beta. Alpha comma beta are the roots of what? Ax square plus bx plus c equals to 0. Alpha comma beta are the roots of ax square plus bx plus c equals to the quadratic equation. Now you can see whenever d is positive, the roots are real and distinct. That's why the graph is intersecting x-axis into different points. For example, if d is negative, what happens? If d is negative, what happens? Now if I say d is negative, second part I will take here. If d is negative, means b square minus 4ac is negative. What is the meaning of this? Whenever d is negative, roots are imaginary. No real roots exist. No real root exists means the parabola never touches x-axis, or even it do not intersect. Neither touches nor intersects. So if you want to see the graph of y is equals to ax square plus bx plus c, in this case d is negative, looks like this. So it is not intersecting, it is not meeting x-axis, neither intersects or nor touches in the case of d is negative. Now you can observe one thing in these two graphs. Here some part of the graph is below x-axis. Can you observe this part? This part of the graph is below x-axis, and some portion of the graph is above x-axis. What is the meaning of this? Whenever a curve is below x-axis, means its function values are negative. So what is the meaning of this? This portion in between alpha comma beta, the part of the graph is below x-axis. In between alpha comma beta, the part of the graph is below x-axis. Therefore, function values are negative. So when the function values are negative, in between alpha comma beta, function values are negative. Outside of alpha comma beta, function values are positive. Because of outside of alpha comma beta, the graph is above x-axis. That's why the function values are positive. So here you can describe this graph like this. In this portion, outside of alpha comma beta, f of x values are positive. Here, whenever in between alpha comma beta, function values are negative. What is our function? Our function is quadratic expression ax square plus bx plus c. And where it becomes 0, particularly at this alpha and at this beta, function values are becoming 0. So here you can see that whenever d is positive, the graph of the ax square plus bx plus c, some part is below x-axis. That means some function values are negative, some part of the graph is above x-axis, therefore function values are positive, and at the point of intersection with x-axis, that is alpha comma beta, at that 2 points function value becomes 0. So there are 3 possibilities. Some are positive, some of them are negative, and at 2 particular points, actually roots, the values are 0. But whenever you see d is negative, what is happening here? Because of there are no real roots, the roots are imaginary. That's why the graph is neither touching x-axis nor intersecting x-axis. Now once again, here we have some function values positive, some function values negative, and 2 particular points function value 0. But here you see the graph is entirely above x-axis. So therefore function values are always positive, means at every point function value is always positive. Because if I take it is 0, function value is here, it is positive. If I take 1 for example, function value is positive. At 2, the function value is positive. So for every real number, f of x is always positive. So therefore, whenever D is negative, with condition that A is positive and D is negative, functional values are always positive. Therefore, f of x is positive. F of x is positive for all x belongs to R. F of x is positive for all x belongs to R. So now, one more case is here we have, that is what? Discriminant is equal to 0. Now I will do that. Now you see, for example, D is equals to 0. That means discriminant is equals to 0 in the case of what? A is positive. In the case of A is positive. So in the case of A is positive, discriminant equal to 0, how the graph looks like. So this is the graph of y is equals to ax square plus bx plus c. So this is the graph of y is equals to ax square plus bx plus c in the case of what? Whenever discriminant is equal to 0. Now you can see that the graph touches x-axis at only one point. Now we know that whenever d is equals to 0, the roots are real. The roots are real and equal. Equal means there is only one root which is repeated. So here that is the root alpha. It touches x-axis at only one point. Okay, so now you can see here once again the graph is above x-axis, totally entirely above x-axis except the point alpha. So what is the meaning of that? Function values are always positive except alpha. Except alpha, if you take in place of x any real number, it will become positive because of the graph is totally above x-axis. So here I summarize these three results. Now you see whatever the results we discussed now, for A is positive. Now I will give you the revision. A is positive. Okay, A is positive and D is positive and D is negative. D equals to 0. Okay, whenever D is positive, the graph of y is equal to ax plus bx plus c is a rough graph of y equals to ax plus bx plus c. Whenever D is negative, that looks like this. Sorry, it entirely, actually it is entirely above x-axis. Entirely above x-axis. So like this. And whenever D is equals to 0, the parabola touches x-axis and rebounces. So here one root we have whenever discriminant is 0, that is alpha. Whenever D is negative, there are no real roots. That's why the graph is neither touching x-axis nor intersecting x-axis. And whenever D is positive, because of it has two real different roots, that's why it meets x-axis in two distinct points. Now one more thing is here in between alpha comma beta, ax square plus bx plus c becomes negative. So ax square plus bx plus c is negative for what? X belongs to open interval alpha comma beta, and it will become positive whenever x is outside of alpha comma beta. It is positive. Now here whenever d is negative, in the case of A is positive, function values are always positive. Ax square plus bx plus c is positive for every x in R. And in this case, whenever A is positive and D is equals to 0, again the parabola is entirely above x-axis except alpha. So therefore, again ax square plus bx plus c is positive for all x belongs to R except this alpha. In fact, that root is minus b by 2a. So except that minus b by 2a, it is always positive. So in the case of A is positive, when quadratic expression will become positive, when quadratic expression will become negative. Now you remember that only in one case the quadratic expression will become negative, that is whenever discriminant is positive, and that is in between alpha comma beta. In remaining all the cases, the graph is above x-axis, and some portion of the graph is also above x-axis, means ax square plus bx is positive, ax square plus bx plus c is positive, and here also ax square plus bx plus c is positive. So there is only one case, that is what? Whenever d is positive, in the case of A is positive, the function values, the quadratic expression will become negative only in between alpha comma beta. if you leave this case in between alpha comma beta, quadratic expression is becoming negative. If you neglect this case, remaining all cases, here we have positive, here we have positive, here we have positive. So therefore whenever a is positive, most of the time ax square plus bx plus c is positive only. So when it will become negative, that you have to remember. When it will become negative, in the case of a is positive, d is positive, and if I say roots are alpha comma beta, in between alpha comma beta, whenever x belongs to open interval alpha comma beta, ax square plus bx plus c becomes negative, except this case. In remaining all cases, ax square plus bx plus c is positive. Okay, so similarly we can discuss whenever a is negative, what happens to the graph of y is equals to ax square plus bx plus c. So you see in the next class. Thank you for watching the video.